Okay, so we've enabled, we can make motion, we've done a subroutine, we've made our code easier to read with defines, and so we've got 4 axes, let's start making multi-axis motion. So we can come into our program, and we're going to copy and paste so we're going to say drive on, and in this section here, let's just add y, change this to y, enabled y, and then this is axis 1. So using the standard default definitions, x is 0, y is 1, and then we're gonna do z and a, and you can do a control H to do a find and replace on the selection, and this will be z, replace all, okay, and then that is axis 2, this is axis 3, and change y to a, just in that selection, replace all, 4, good. All right, so we are now using some new defines. We need to add those in. We can come into the defines. Y, Z, A. Now the bits, if we look at the motion status panel, axis 1, drive enable bit is 8497. So the bits actually increment by 32 on each axis. 8529. And then the last would be 8561. And then looking at the program, we've enabled the drives. We would want to reset the positions. If we've already tested those, they may not be at 0. And then we can move them all at the same time. Let's go ahead and move the same distances. And then come back to the starting position. Okay, and then we're going to download. Make sure you include the defines, as we've added some there. On the defines, after you download the first time, it thinks you're redefining. That's just really a warning. You can ignore those errors on the top there. We haven't actually changed those. If you do change them, you need to download the entire drive configuration in addition to the defines, so that it reallocates those in memory. Let's test our motion. Let's go in the terminal emulator. Four axes, all enabled and all moving together. Very cool. And that is the beauty of the ACR. It's very easy to make multi-axis motion by default. It's just X, Y, Z, A. If you wanted to do different positions, you could do X5, Y1, Z3 if you wanted just to do an incremental move with the slash. So /2 would increment out from wherever it is. It would increment out 2 units. We could make that negative, so, and it would reach this position all at the same time. So it would change the individual axes velocity. The path velocity would be 1, but the individual axes velocity would change so that it all reaches the same position at the same exact time. These can be individual axes, so you could do x0 and then have it come back to 0 before moving back the other 3 axes. Yeah, let's try that. Let's download. Okay, and then if we run the program, so it's going to move to Y5, X5, Y1, and then move back to 0 on X, and then come back on the other 3 axes back to the 0 position. Okay.